Okay, you are given this question. A uniform 1 meter rod of mass 50 kg is suspended horizontally by two wires attached at 30 cm and 90 cm respectively from the ends. Calculate the tension in each wire. So how do we solve this? You have a uniform rod. The rod is 1 meter. So 1 meter is equivalent to 100 centimeter. So you have the rod is 1 meter, which is 100 centimeters. So you have here as 0 cm, you have here as 100 cm. When we say the rod is uniform, it means that it's very straight. Now, the center of gravity is the point at which the resultant weight appears to act. So we assume here to be the center of gravity is at 50 centimeter because it's up to 100 centimeter and it's a uniform rod. So what to do here is the weight of the body lies at the center of gravity, which is 50 kg. So the weight of the body is giving us 50 kg. Oh, we cannot use this directly. What we do is weight is giving us mass times acceleration due to gravity. So the mass is 50 kg times acceleration due to gravity is 9.8. And we multiply this, you're going to have 490. You're going to have 490 Newton. So the weight of the body is 490 Newton. Okay. Now it's suspended horizontally by two wires attached. So it's suspended horizontally. The first wire is attached at 30. So from here to here is 50. From here to here is another 50. So 30 cm is somewhere here. Somewhere here is 30 cm. Okay, this is 30 cm here. Now another one is placed at 90 cm. That means we have another one placed at 90 cm. This is 90 cm here. Okay. Now what to do? From here to this place, it's going to be 50 minus 30. 50 minus 30 will give us 20 cm. From here to here, it's going to be 90 minus 50, which is going to be 40. So you're going to have from here to be 40 cm. Now, from here to this place, it's going to be 20 cm plus 40 cm, which is going to be 60 cm. Or you can equally say 90 minus 30, which is also 60. So here to here is 60 what? Cm. This is tension 1 and this is the tension 2. Okay? Now you're asked to find the tension 1 and tension 2. Since the rod is in equilibrium, two conditions are applied. One, some of the moments of the body at a particular point must be equal to 0. Two, some of the upward forces must be equal to some of the downward forces. So let us follow the first condition that says some of the clockwise moments must be equal to the sum of the anti-clockwise moments. Let's assume we're taking our moment at a point 90 cm. Taking moments, we say taking moments at 90 cm points. Okay? If we take our moment at this point, all the forces will be directed towards that point. The point, if you want to find T1, you take moment about T2. If you want to find T2, you can take moment about T1. So if you take moment about T2, all the forces will be directed towards T2. Okay? But if you take moment about T1, all the forces will be directed towards T1. Now we're taking moment about 90 cm. That is at point, 90 cm point. That is this point. So all the forces will be directed towards that point. Okay? Now, if you look at this is a clockwise moment. We call this clockwise moment. This is anti-clockwise moment. Okay? Now, sum of clockwise moments must be equal to sum of anti-clockwise moment. That's one of the conditions since it's a uniform rod. Sum of the clockwise moments, this is a clockwise moment. You have T times the distance from here to here is 60. So you're going to have T1 times 60 equal to, this is a clockwise moment. This is the anti-clockwise moment. That is 490 times distance from here to here is going to be 40. So you are having 490 times 40. That is 490 times 40. Okay. Now I'm looking for T1. T1 is going to be 490 times 40 over 60. Okay. That is, let me put it here. That is, T1 is 490 times 40 over 60. Over 60, okay? Now, you are going to have this, we cancel this. 2 here is 3. 2 here is 2. 2 here is 2. Now, how we multiply this by this? T1 will give us 980 over 3. And 980 divided by 3 is approximately 327. 327 Newton. That is the value of this T1. How do we find T2? We take the second condition that says some of the upward forces must be equal to the sum of the downward forces. So what are the upward forces? This is the upward force. This is another one. So we are going to have T1 plus T2 is going to be equal to the downward force. That is, the downward force is 490. We've already gotten T1 as 327 plus T2 will give you 490. So T2 will give us 490 minus 327. So by the time we do that, our T2 will give us 163 Newton. Okay, that is the tension T2. This is the tension T1. Now, having gotten this, this is how we can solve this problem. Now, you can subscribe to our YouTube channel or follow us on our Facebook page at Easy Physics with Vincent. Invite your friends. Thank you.